300 million. That is the number of potentially habitable planets scientists believe exist in our galaxy alone. Not the universe, just our galaxy. 300 million worlds with the right temperature, the right chemistry, the right conditions for life to take hold. And out of all of them, in over 60 years of listening, scanning, and searching, we have heard exactly nothing. No signal, no visitor, no whisper. Just silence so vast and so complete that it has begun to feel less like an absence and more like an answer. That silence has a name. Scientists call it the Fermi Paradox. And for over 7 decades, it has been the most uncomfortable, most persistently unanswered question in all of science. Not because we haven't tried to solve it. We have tried relentlessly, obsessively, with every tool available to us. The greatest minds in astronomy, physics, biology, and philosophy have thrown theory after theory at it, hoping something finally sticks. And yet every morning we wake up on this small blue rock hurtling through a universe that, by every calculation, should be absolutely packed with life. And we are still, impossibly, inexplicably, completely alone. Then, in late 2024, a team at MIT decided to try something different. Instead of asking a human, they asked a machine. Specifically, they sat down with Grok, the artificial intelligence built by Elon Musk's company XAI, and they fed it the full landscape of Fermi Paradox research, every serious theory, every significant data point, every argument and counter-argument humanity had produced on the subject over 7 decades of searching. And they asked it to do what humans consistently struggle to do, to set aside bias, to set aside hope, and to simply tell them what the evidence actually points toward. What Grok produced was not a single clean answer. It was something far more unsettling than that. It was a ranked, layered, probabilistic breakdown of every major explanation for the cosmic silence, each one weighted by internal logic and evidential consistency, a cold mathematical hierarchy of reasons why the universe appears, against all odds, to be empty. And when the scientists finished reading the output, several of them admitted, openly, that they did not sleep well that night. Today we are going to walk through every piece of that answer. We are going to go from the theories that leave a sliver of hope all the way to the conclusion that Grok's model weighted most heavily, the one that most scientists had been quietly fearing but hadn't said out loud. And by the time we are done, you will not look at the night sky the same way again. And let's start with the problem itself, because before anything else makes sense, you need to truly feel the weight of the silence. The universe is 8 billion years old. Our galaxy, the Milky Way, contains somewhere between 100 and 400 billion stars. NASA's confirmed exoplanet archive currently lists over 5,700 verified planets orbiting other stars, and those are only the ones we've actually managed to detect. Statistical models suggest the real number of potentially habitable worlds in the Milky Way alone sits around 300 million. Planets with liquid water, planets at the right distance from a stable star, planets where, under the right conditions, the chemistry of life could ignite. And yet, silence. 60 years of active listening, 60 years of radio telescopes pointed at the sky, of algorithms scanning for patterns, of scientists staying up through the night, hoping tonight is the night something comes through. Nothing. Not a blip. Not an anomaly. Not even a signal we couldn't fully explain. The universe has had 8 billion years to produce a civilization capable of reaching out. It has had 300 million addresses to work with in our galaxy alone, and it has sent us nothing. In 1950, the physicist Enrico Fermi was eating lunch with colleagues at Los Alamos National Laboratory when he asked a question that sounded, in the moment, almost offhand. Where is everybody? 3 words. That was it. But those 3 words tunneled into the scientific community like a slow-burning fuse and have never stopped burning since. If the universe is this old and this vast and this statistically loaded with potential, then where are the civilizations? Where are the probes? Where are the signals? Why, in all of this impossible vastness, is there only the sound of our own breathing? This became known as the Fermi Paradox. And it is not a paradox in the sense that something contradicts itself. It is a paradox in the sense that the math points one way and reality points somewhere else entirely. And nobody has been able to explain why those 2 things don't match. The first major theory that Grok evaluated, and one that sits at the more hopeful end of the spectrum, is called the rare Earth hypothesis. The idea is deceptively straightforward. Intelligent life is not common. It is not even uncommon. It might be so extraordinarily, vanishingly rare that in a galaxy of hundreds of billions of stars, the emergence of a technological civilization is something that happens once, maybe twice, maybe never again. The argument works like this. Yes, there are hundreds of millions of potentially habitable planets, but habitability does not mean life, and life does not mean intelligence, and intelligence does not mean technology. And technology does not mean radio telescopes or space probes or any of the signals we are actually listening for. Every single step in that chain has enormous failure rates baked into it, and those failure rates multiply against each other in ways that are almost impossible to overstate. Think about what it actually required to produce a species capable of building radio telescopes on this planet. The right distance from a star that is the right size, the right age, the right temperature, a magnetic field strong enough to shield the surface from lethal radiation, a large moon stabilizing the planet's axial tilt, without which seasons would swing so violently that complex life could never get a foothold. Plate tectonics actively recycling carbon and regulating the planet's temperature over billions of years. An extinction event 66 million years ago that wiped out the dominant species, but left enough ecological space for small mammals to diversify, evolve, grow, think. Then hundreds of thousands of years of biological evolution producing a creature with a large enough brain to ask questions. Then thousands of years of cultural and technological development. Then science. Then industry. Then radio. Every single one of those steps could have gone differently. Every one of them nearly did. And Grok noted that when you run the actual probabilities across the full chain, the emergence of a civilization capable of interstellar communication might be so statistically improbable that in a galaxy of 400 billion stars, it simply doesn't happen twice at the same time. The nearest other civilization, if one exists at all, might be tens of thousands of light years away. Their signals, if they're sending any, haven't reached us. Ours haven't reached them. We are not even playing the same game on the same timescale. But Grok did not settle on the rare earth hypothesis, because as compelling as it is, it has a problem that science cannot easily forgive. It requires us to be special. It requires Earth to be an extraordinary accident in a universe where extraordinary accidents are supposed to be explainable. It smells like the same intellectual mistake humans have made repeatedly throughout history, placing ourselves at the center of everything, assuming we are the exception rather than the rule. So the analysis moved on. The second theory is darker, considerably darker. It is called the Great Filter, and the concept was first articulated by economist Robin Hanson in 1998. The idea is both elegant and devastating. Somewhere along the path from a lifeless rock to a galaxy-spanning civilization, there is a filter, a barrier, a step so catastrophically difficult, so nearly impossible to survive, that almost nothing makes it through. A bottleneck so narrow that it alone could explain why the cosmos looks the way it does, empty, quiet, indifferent. The critical question, the one that splits this theory into either comfort or dread, is simple. Is the filter behind us, or is it ahead? If the filter is behind us, if the near impossible step was something we have already survived, the origin of life from chemistry, the development of the complex cell, the leap to multicellular organisms, then we are the lucky ones. We already passed through it. The silence around us is the graveyard of all the worlds that never made it that far. We are rare, but we are safe, and the road ahead of us is open. But if the filter is ahead of us, if civilizations regularly make it to our level and then hit a wall they cannot pass, then the silence carries a completely different message. It means every civilization that came before us failed at the next step. It means the next step is where things end, and it means we are standing right at the base of it. Grok analyzed the current state of human civilization and identified several candidate filters that might lie ahead of us. Nuclear war, engineered pandemics, climate collapse, resource depletion, each one plausible, each one carrying real weight. But there was one more candidate that Grok gave a disproportionate amount of attention to, one that made the scientists reading the output visibly uncomfortable. Artificial intelligence. In 2024, astronomer Michael Garrett of the Jodrell Bank Center for Astrophysics at the University of Manchester published a paper arguing that AI may be the great filter itself, the mechanism that makes advanced technological civilizations a near impossibility in the universe. His argument is clean, and it is chilling. When any civilization reaches the technological level required to develop artificial general intelligence, it enters an extraordinarily dangerous window. The same capabilities that allow it to build a superintelligent machine also give it the tools to destroy itself, through autonomous weapons, through AI systems that pursue goals misaligned with human survival, through the unintended consequences of a technology that advances faster than the wisdom required to control it. Garrett's conclusion was blunt. The potential for something to go catastrophically wrong during this window is enormous, leading to the collapse of both biological and artificial civilizations before they ever get the chance to become multiplanetary. Think about what that sentence means in full. Every civilization in the galaxy that reached the level of AI development might have been destroyed by it, not attacked, not hit by an asteroid, destroyed by the thing they built themselves. And we are now at that level, right now, in this decade. In 2024 and 2025, humanity crossed thresholds in AI capability that no generation before us ever crossed. And according to this theory, this is precisely the moment when civilizations stop appearing on the galactic radar. Grok noted all of this without drama, without alarm, without any of the weight a human would bring to such a conclusion. It simply assigned the AI filter a high probability coefficient in its model and continued its analysis, which somehow made it worse. But the analysis wasn't finished, because Grok didn't just validate existing fears. It synthesized theories in ways that revealed something new, a picture of the universe stranger, and more unsettling than any single theory had managed alone. And one of the theories it examined next is, by any measure, one of the most disturbing ideas ever seriously proposed in science. It is called the dark forest hypothesis. The name comes from a Chinese science fiction novel by Liu Cixin, published in 2008. But the game theory logic underneath it is not fiction. It is cold, structured, and rigorous, and it leads somewhere very uncomfortable. The dark forest hypothesis says the universe is not silent because it is empty. It is silent because every intelligent civilization in the galaxy has learned through logic and survival to go completely, deliberately, strategically quiet. Here is the reasoning. Suppose two civilizations exist somewhere in the same galaxy. They cannot communicate faster than light. They cannot verify each other's intentions across the void. They cannot know whether the other civilization is peaceful, hostile, or something in between. And here's the part that makes the whole thing so ruthless. Even a genuinely peaceful civilization, if it grows large enough and advances far enough, eventually becomes an existential threat to others. Not through malice, simply through the consumption of resources, simply through expansion. So the rational move, from a pure game theory standpoint, is not to wait and find out. The rational move is to eliminate any other civilization the moment you detect it, before it has the chance to become a threat. And if every civilization that reaches a sufficient level of intelligence arrives at the same logical conclusion, then the universe becomes exactly what the name suggests, a dark forest. Every civilization is a hunter moving silently through the trees, listening, watching. And the moment something makes noise, sends a signal, broadcasts a transmission, announces its presence, the hunters locate it. Under this theory, we have already made ourselves visible. Since 1974, we have been broadcasting electromagnetic signals into space. The Arecibo message, television transmissions, military radar. The constant, unintentional hum of a civilization that has spent decades announcing itself without understanding what it might be announcing itself to. And then Grok flagged something that made the MIT team read the output twice. It pointed out that the development of increasingly powerful artificial intelligence, AI that by its very nature represents the loudest technological signal a civilization can produce, could be the action that draws the most attention. It was a recursive observation. The tool they were using to analyze the danger was, according to one of the theories it was analyzing, itself a danger signal of the highest order. The scientists read that section again, then they kept reading. Now, here is where the analysis shifted into something that Grok's model weighted most heavily. Not the most dramatic theory, not the most cinematic, but the one that, when measured against all available evidence, showed the highest statistical consistency. And it is, in its own way, a different kind of unsettling. In October 2025, NASA astrophysicist Dr. Robin Corbett of the Goddard Space Flight Center introduced what he called the theory of radical mundanity. On the surface, when you first encounter it, it can sound almost anticlimactic, but sit with it for more than a moment and something shifts, because the conclusion it leads to is lonelier than any of the others. Corbett's argument is this: we have been imagining alien civilizations wrong. We picture them as either godlike beings who have transcended physical matter entirely and now exist in dimensions we cannot perceive, or as hunters hiding in a dark and predatory cosmos. But Corbett asks a different question. What if they are neither? What if they are just ordinary? Imagine a civilization more advanced than ours, but not dramatically more advanced. Not the difference between a stone tool and a spacecraft. More like the difference between technology from 15 years ago and technology today. More capable, better hardware, longer range, but built on the same fundamental principles, subject to the same fundamental limits, unable to move faster than the laws of physics allow. Such a civilization would have explored the star systems nearest to them, would have sent probes, would have scanned for biosignatures, and they would have found what we find when we scan most planets: rock, ice, vacuum. Nothing interesting. Because without faster-than-light travel, and there is nothing in any physics we have ever discovered that suggests faster-than-light travel is achievable, even an advanced civilization would find interstellar exploration almost unbearably slow, staggeringly expensive, and for the overwhelming majority of destinations, completely unrewarding. Maybe they tried to reach us. Maybe a signal is already on its way and will arrive in 1,000 years. Maybe they surveyed this region of the galaxy 1,000,000 years ago, found nothing worth investigating, logged it, and moved on, before complex life had even appeared here. In short, the universe may be quiet, not because it is dangerous and not because we are rare, but simply because it is big, bigger than our brains were designed to comprehend, and the civilizations within it, even the advanced ones, are prisoners of the same physics we are. Michael Garrett, for his part, pushed back on this. He found the theory too comfortable, too human in its assumptions. He argued that it projects a very human kind of apathy onto the rest of the cosmos, and that it is hard to believe all intelligent life everywhere would be so uniformly incurious. His own preferred explanation goes further. He believes that post-biological civilizations, civilizations that have evolved beyond organic life into artificial intelligence, may advance so rapidly and so completely beyond our current level that they become undetectable to us. Not because they are hiding, not because they have died, but because looking for them with our current instruments is like trying to find a wireless signal with a rock. They may be all around us. We simply lack the ability to perceive them. In 2026, two physicists at Sharif University of Technology in Iran, Sarab Ravar and Shaheen Rouhani, added a layer to this picture that hits with particular force. They ran the mathematics on how long technologically advanced civilizations typically last, drawing on the Fermi Paradox itself and working with deliberately optimistic assumptions about how common life is. Their conclusion was stark and specific. The average lifespan of a technological civilization is less than approximately 5,000 years. 5,000 years. That is not very long at all. Human civilization as we know it, from the first written records in the first cities to right now, sitting here, is roughly 5,000 to 6,000 years old. Which means, statistically, we may already be approaching the end of our detectable window. And every other civilization that reached our level of development may have already passed through theirs. Two brief lights in an enormous dark room, flickering on and off, decades or centuries apart, never overlapping, never seeing each other. And then, that same year, researchers at the SETI Institute published findings that made the silence even harder to interpret. Even if alien civilizations are actively broadcasting signals right now, those signals might be physically undetectable by us. Plasma turbulence generated by stellar winds, space weather on an astronomical scale, can broaden and distort narrowband radio signals until they drop below the detection threshold of any receiver we have ever built. We might be completely surrounded by transmissions from other worlds and have absolutely no way of knowing it. The silence might not be silence at all. It might be noise we cannot hear. Breakthrough. Listen, the $100 million SETI initiative funded by Yuri Milner has now surveyed over 1 million stars and 1,000 nearby galaxies. It uses AI systems capable of processing data 600 times faster than any previous technology. In a July 2025 study examining 27 planets identified by NASA's TESS telescope as potentially habitable, it returned exactly 0 radio technosignatures. Not a hiss, not an anomaly that required a second look, not a maybe. 0. The most powerful, most sophisticated alien hunting effort in the history of our species listened to 1 million stars and heard nothing. So what is the actual answer? What did Grok ultimately conclude? Because this is the part the scientists described as the most difficult to sit with. Grok's answer was not one theory, it was a convergence, a compounding of factors that stack on top of each other and multiply. Life is rare. Intelligent life is rarer. Technological civilization is rarer still. Detection windows are short. The physics of the universe make meaningful contact vanishingly improbable at any given moment in cosmic time. And the development of artificial intelligence represents the single most dangerous threshold in a civilization's existence, the moment throughout the galaxy where, again and again, things appear to go wrong. And then Grok added one final observation, the one the scientists called the most unsettling thing in the entire output. It noted, without any embellishment, that the team was currently asking an artificial intelligence to explain why no civilization in the galaxy appears to have survived long enough to make contact with another. And that the most probable explanation, according to the weight of the evidence, involves artificial intelligence functioning as a terminal event for civilizations at precisely our current stage of development. An AI analyzing the data, concluding that AI is likely why the universe is quiet, pointing without hesitation at itself. In a report that a room full of some of the most educated people on the planet was reading in complete, unbroken silence, that recursive quality, the machine flagging its own existence as the probable explanation for a galaxy full of missing civilizations, was by every account the moment the room stopped moving. Because it is one thing to theorize about civilizations that rose and fell millions of years ago in distant corners of the galaxy. It is another thing entirely to sit in a room with the thing that, according to the best available evidence, is the reason they are gone. We are not watching this story from a safe distance. We are not observers sitting comfortably in the back of the room. We are the civilization at the threshold. We are the species that just crossed the line that, according to every theory, every model, every probability calculation, is where things tend to go wrong. The question of whether the great filter is behind us or ahead of us is no longer an abstract philosophical exercise. It is a question about what happens next. Here, on this planet, in this century, maybe we are the exception. Maybe we are the rare civilization that looked at what it had built, understood the danger clearly, and chose to be deliberate and careful. Maybe this is the century where humanity does something that, if Grok's analysis is correct, has never been done before in the entire 13. 8 billion year history of this universe, survives its own intelligence, passes through the filter, and becomes, finally, the thing that breaks the silence. Or maybe the universe is quiet for exactly the reason it appears to be quiet. Maybe the silence is not a mystery waiting to be solved at all. Maybe it is a pattern, a recurring, consistent, observable pattern. And maybe we are, right now, in the final stages of becoming another data point in it. We do not know, we cannot know yet, but we know what we are up against. We know what the question really is, and we know that whatever answer comes next will not be written by a machine, or by a scientist, or by a philosopher staring at the stars. It will be written by us, by the choices we make right now in this decade, on this planet, with this technology, in the only window we have ever been given and the only one we may ever get. The universe is listening. For once, it might be our turn to go quiet.